Okay, so ran out of time on this one. And then I kind of had your final structure, but what I really should have done is rewrote it, kind of cleaned it up. So I'm just going to rewrite. I'm going to clean the structure up. So like here's the structure, right? But that's it's kind of a mess. So I'm just going to clean it up. And so it basically look like this. So you'd have an O, you'd have CO2 would be an O, a double bond, a C, another O, and then you'd have some dots over here, and there we go. And so that's kind of what the final cleaned up one would be. Once again, you could have substituted in a triple bond instead of two doubles, so a triple and a single, and that would be fine as well. And we're going to get to that in a bit, where there are options and like how do you find the best option. So same pattern. The only difference here is this one did not have a charge, right? So if it had a charge, I'd have to put those brackets around it. And this one doesn't have a charge, so I can just leave it like that. So, all right, let's jump over here. Write the Lewis structures for, and we have some for you to practice. So I would like you to try to do these. I will say that number 2 doesn't have a central atom. It has two central atoms, so the nitrogens are hooked up, and then the hydrogens are symmetrical. So not everything is going to be 100% with the central atom, but that's okay. You can still figure that one out. And this one only has two atoms, so you just connect them together, but you still use the same rules to see what the best options are. So pause this, see how you can do. All righty. Number 1, I'll put the nitrogen in the middle, like so, and attach a couple of O's. So put an O here and put an O here. Now fill them up to 8. There we go. There we go. Very important to fill them up to 8. Okay, now we got to figure out how many electrons we're going to be allowed to have. And so when you look these up on your periodic table, oxygen is going to give you 6, and there's 2 of those, so that's 12. And then nitrogen is going to give you 5. And then you're probably like, what the heck? I'm stuck. Like 17. Well, you also have this -1. So does that mean you get an extra electron or you lose an extra electron? Well, -1 means that you get to gain 1 extra. So the -1 actually is 1 additional. So it's 12 and 5 and 1. So that's 17 plus 1, 18. That's going to be your target. Like so. Okay, so we got to get this to 18. So what the heck does this have? Well, let's count them. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 20. Well, 20 is not 18. So what do? We put a bond in. You can put your bond in wherever you like. So you could put it here or you can put it there. It doesn't really matter. You just only get to add 1. So let's add the new bond. I'll just put it right there. And then we'll go ahead and cross those out. And if you recount, you're going to get to 18. I will show you if you don't believe me. 2, 4, 6, 8, 10, 12, 14, 16, 18. Now notice I took the electrons, a pair from each side of the new bond. So students always sometimes struggle because they want to do things too fast. So you always add the bond and then you cross off 2 sets of lone pairs. Okay, that's the order. Bond first, then you cross them off. Okay, all right. So I'd probably rewrite this real quick, make it look a lot cleaner. So it'd probably be like this, double bond like this, and then I'll put my dots in. That wasn't a very good dot there. I'll move those to the bottom just for some space, it's not going to matter. There we go. Let me clean these up a bit. There we go. So that's kind of what it would look like. And then I would add a bracket. Gonna kind of run into my other problem here. You see here, I'm gonna add a bracket like this. And then I'm gonna put in a -1 right there. Okay. Because you do need that that bracket because of the charge. Because once again, the reader has no idea that it has a charge just by looking at the shape that you draw. So, all right, let's do the COS. Let's go ahead and get rid of that little hint. COS. Do it in a different color. Do the green. So put the carbon in the middle. Carbon loves being in the middle. And oxygen. Let's go a little higher here. Carbon. Not that it matters. There we go. This side doesn't matter. You could put the sulfur on their side, oxygen on the other side. Doesn't matter. So let's fill them up to 8. And let's go ahead and figure out the target number. So what's the target number here? So let's like kind of figure that out. So switch colors real quick. So the carbon is going to give us 4. It's in column 4A. You can look that up on your periodic table. So it's in column 4. On the oxygen, you guys are maybe starting to figure this out. It gives us 6. And the sulfur also gives us 6. Carbon and sulfur and oxygen are going to all add up, and there's no charge here, right? So this one had this -1 charge, right? That was a bit of a difference maker, which added 1. So these, though, 6 and 4 and 6, just going to have a target number of 16. And I will say that the target numbers should be positive. If they're negative, I'm sorry, not positive. Yeah, they should be positive. They should be even. If they're odd, that's a bit of an issue. So let's count up what we got here. Maybe you're starting to see a pattern. This is going to be 20. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 20 is too much. So let's go ahead and add a bond. I'm going to go ahead and do a different color. I'm going to go ahead and add a double. Count again, 2, 4, 6, 8, 10, 12, 14, 16, 18. So we're at 18, but 18 is not 16. So we got to go again. And you could do a double or triple. I'm just going to do 2 doubles. And 2, 4, 6, 8, 10, 12, 14, 16. Very cool. We have our structure. So let me clean it up a little bit. It would look like this. O, double bond, C, double bond, S. That didn't look that great. Let's try it again. O, there we go. Double bond C, double bond S. This will have a couple of dots on it. That's sulfur. And then this oxygen will also have a couple of dots on it like that. And then there you go. All right. This like N2H4, what happens is since you don't have a central atom, you end up with 2 central atoms. And so it's going to look like this, nitrogen connected to nitrogen. Then these H's will be split out between the nitrogens. So put an H here, put an H here. You can put them on top if you want, but it doesn't matter. Remember, H's, no dots. No dots for H's. They are too small for dots. They don't get any dots. And so the N's do. Target number here. Nitrogen. Target number of 5, and there's 2 of them. And then hydrogen is in column 1. So, and there are 4 of them. Target number 14. There's your target number. And what you find a lot of times on these ones that don't have central atoms is they normally just work out. You don't have to do that much. So if we count 2, 4, 6, 8, 10, 12, 14, boom, it does work out. So you kind of put this one together and it's done. And let's finish out with this carbon monoxide, C connected to O. Still dot them up, make them nice and stable. Carbon's going to give us 4. Oxygen is going to give us 6. That's 10. So we're allowed to have 10. What do we have? 2, 4, 6, 8, 10, 12. We have 12. So that's too many. 2, 4, 6, 8, 10, 12, 14. Yeah, I thought I miscounted that. Sorry. Sometimes I do that. I'll just be zipping along and I'm just going 2, 4, 6, and I kind of skip one. So 2, 4, 6, 8, 10, 12, 14. Yeah, so like I was wrong there. I thought so. 14. So let's go ahead and 14 is the target number, not 12. So 14, and we got to get down to 10. So that's going to take you to 12. And that's going to take you down to 10. 2, 4, 6, 8, 10. Yep, that's 10. Once again, when I count them, you just 2, 4, 6, 8, 10, and we're good to go. So I clean it up a little bit. No need for a bracket. Doesn't have a charge. Pencil's also good for this. I mean, I've got this pen that can be erased, but when you're working these, you do a lot of erasing of things, so it might be kind of nice to have a pencil on that. So, all right, that is Lewis dot structures. So we're going to pick up here next, resonance structures. These are ones that where you have all kinds of things that are kind of the same, but just slightly different. So we'll pick up there. You'll have practice with this. You do need to know this. I will say that if you can't do this, it's a huge problem because so many things in this unit are based upon our ability to draw the dot structure. So have good notes here. Have done hopefully you did a good job with that example problem of the carbon dioxide. The only thing you haven't seen the expanded octets where we'd have to add extra electrons into the middle spot. You haven't seen that, but that's okay. Just right now, we've got to be able to do well on these.